Hi everyone. About this session, I'm expecting like you all are having basic programming knowledge and some background knowledge about the big data, like what is the big data is all about, and what kind of things, what are the areas in which big data we can implement. So regarding the big data, as all of you know, like in every 60 seconds, we are having so many activities, like 168 million emails are sent in the world, and we are having 60 plus new blogs have written, 70 plus domain are getting registered, and 600 plus new videos are uploaded over the YouTube. So we are having so much of data which we need to monitor, and we need to process that, as well as we need to maintain that big amount of data. So because of that, traditional database system and traditional processing is not sufficient to work. So then we come up with a concept of this big data, which follows the 4 V's, like one is velocity, veracity, volume, variety. Variety. These are the 4 V's, which are the properties of any big data. So if I give you an example, like suppose we are having 10 TB of data in our hard disk, and the transfer rate is 100 Mbps. Then how much time it will take to read the data? So I can tell you, like 10 TB means 10 multiplied by 10 to the power 12 divided by 100 Mbps. We are having the speed means 100 multiplied by 10 to the power 6. So it means we will have around 27 hours of the time it will take. But that is our traditional. But if we will use the Hadoop framework, in that case, if we are having the 100 different machines, so we can accomplish this task within the 17 minutes. So that is the benefit of using this big data. So under big data, we come up with a solution, like we need a reliable and distributed storage, that is SDFS, and an analysis system we need, that we are doing using the MapReduce or Spark, anything. So let I go to the first slide. This is Spark 1. So I need to tell you, like why we are using the Spark. So there are the certain scenarios where MapReduce got failed. So like when we are using, when we are working on the terabytes of the data, possibly even more, if you keep writing the data to the hard disk, and it will be extremely costly, and it will be extremely slow as well, because writing to the disk and reading from the disk is always a bottleneck, always a slow operation. Because of this limitation, if you want to change something in your query or want to rerun it, that will take again whole cycle of reading from the disk and writing intermediate data to disk, and then again reading, writing. So it will take unacceptable long time. And like we are having few scenarios, like we are having interactive algorithm or streaming application where MapReduce is not feasible to work. So then we come up with a scenario of this Spark. So Spark is basically a fast and general engine for the large scale data processing, that is built around the speed and the easy to use, which is a main property of Spark. So it is having few features, like speed. So high performance for both the batch as well as the streaming data, because it uses the DAG scheduler, query optimizer, and physical execution engine. So it runs workload about 100x faster time than our traditional flow. Second advantage of using Spark is it is easy to use. So write applications, we can write the applications quickly in the Java, Scala, Python, R, or SQL, any languages. And Spark offers over 80 high-level operators. And interactively with Scala, Python, R, and SQL. The word interactively means like you can run one line of the code and check the result. No need to run whole the code. You can test your individual line of the code as well. Third features which Spark provides is generality. So it provides a library, SQL, and data frames, MLIB for machine learning, GraphX and Spark Streaming. So you can combine these library in your same application and you can utilize them and you can get the advantage from them. Fourth feature is it runs everywhere. So you can run Spark on its standalone mode, cluster mode, or in EC2 or Hadoop Yarn or Kubernetes or Mesos. Like you can access the data in the SDFS, Apache Cloudera, Apache HBase, Hive, or 100 of other database across. So these are the features which Spark supports. So next I take you to one of the diagram. So you will get better clear picture on this. I'm assuming like you all aware about this very basic diagram of name node and data node. Like this is name node and this is our resource manager as well. These are 4 data nodes which we can tell this as the name node as well. So data node 1, 2, 3, 4. So I'm giving a scenario like suppose we are having total 48 GB of RAM and 24 TB of hard disk and 12 CP of core processor CPU you are having. Then in that case, I'm assuming like each of the data nodes having this configuration, each of the machine having this configuration. So if I will tell you like out of these 48 GB RAM, let me consider only one parameter, that is RAM. Out of this 48 GB, first one is 4 GB memory is allocated to the operating system to run your program. Second, 4 GB is allocated to, one second. The second 4 GB is memory is allocated to your node manager. This is node manager you are having. Next, we are having, suppose we are giving 4 GB memory to allocate to your data node. Likewise, you are having, you already allocated 12 GB of RAM already. So your remaining memory would be 48 minus 12, that is 36 GB. And if we multiply by the 4, because we are in the 4 data nodes, then you are having total 144 GB of total memory in 4 worker computers. So this 144 GB will be divided into our containers. So let I assume like I'm working on 4 containers. So I'm having 4 part here. So each of will be having 9 GB memory. I hope you are having the visible here. This is having the 9 GB, this is having the 9 GB, 9 GB and 9 GB. I'm having like this, each of the worker computer in each of the container having the 9 GB of memory. So total we are having 144 memory is a free memory or disposable memory which is available along the cluster. Under this we are having only 144 memory GB of memory remaining, because we already divided for the operating system, for the allocation of node manager, for the allocation of data node. So if I go and load some data which is less than this 144 GB of memory, my entire processing will happen in the memory and no disk hit at all. And right from the reading the data until the processing end to end and getting the results. Whereas if the input size is higher than the memory size, that is more than 144 GB, unfortunately the total memory based processing will not happen. That's where some data will load into the memory, it will process there, it stores the result back into the disk, and then some other data will load into the memory, and like that operation will go on. But if your data set is small enough to fit into the memory of the cluster, then while processing will happen in the memory end to end, like right from the reading and then processing end to end and then producing the results. That's one of the primary reason why Spark is so fast. And if we consider a typical production environment, we will have around 100 to 200 computers with 128 GB of the RAM each. So I am considering like I am having 100 computers and each of the having the 128 GB of RAM. Then you will have approx 12 TB of the memory you are having. So in that scenario, if you remove some allocation to the memory domains as well, then the remaining would be, I can consider it like I can remaining as the 10 TB of the memory. So in this case, if your data less than the 10 TB, then it will entirely process within the memory itself. No need to go to the disk anyway. So higher the memory in the computers, more and more in memory processing, data processing will happen, which is the next point in our PowerPoint presentation, like higher the memory. So it is totally based on the RDDs. RDDs are the data sets which are distributed across your memories. Let I move to next slide. These are some of the common features which RDD is having, like RDDs are in-memory abstraction of Spark. These can be built by loading the data from the input source. These are made up of the partitions, and content of RDDs cannot be edited, which is the most important point to be remember. Generally used to be asked within the interview questions. And RDDs loaded the data will be divided into the multiple partitions and spread across the cluster. So let's take some example here as well. Yeah, so I'm using Scala programming for this. Just understand the concept. There is nothing much to be there. If you know the basic programming, then also you will cover easily. There is nothing, only the syntax and other things is not a big deal here. So I'm just trying to create one RDD, which is well TIMP. That is T stands for some telecom data I am having. INP stands for input, and val is the keyword which we use for creating the RDDs, and to the sc.text file, and I'm giving some path here. Suppose this is the first statement in my program, and it while executing it took around 50 GB of memory. So like our telecom data is 50 GB, then this 50 GB will be divided and loaded into our memory. So now in the second step, what we are doing is like I am having a file which consists of the telecom data, and it consists of the 6 column values. And after each line, it is splitted by using the semicolon. So in the second step, after loading the data, we will split this value. So for that we will write this. We will create one more RDD, that is telecom INP splitted one equals to telecom input, and I am applying here some split function. As of now, I am just covering the concept of memory and not about the programming. So let us assume like this will also take 50 GB of memory in our second step. So now from our 144 GB of memory, which we discussed in our paint diagram, first 50 GB occupied by the original data and next 50 GB is occupied by the splitted data. So these will be called as the RDDs, which I created here. These are called as the RDDs, TINP and TINPS. So in the third step, I applied some operations of map. Like I created one more TINP as 2 equals to TINP as dot map function I did. And suppose it is taking 20 GB of data. Then assume result of the map operation, it is taking 20 GB. In the third step, we are getting one more RDD, T3 equals to TINPS of 2 dot. I'm applying some group by operation. Assuming that this is also taking 20 GB of memory. In the next step, we are creating one more val of T4 equals to T3 dot map operation I'm performing. Basically, this program, what I'm trying to write is I'm having one telecom data which is having user details, like they are having some phone numbers, and we want to know like what is the mobile number wise call total duration. So for that, this program will get work. This is not the exact program, and even the this is under map also we need to write the command as well, how it will map. But I'm just right now considering about the memory size, how in memory processing at work. So suppose this last our operation map function will take 20 GB of space, but we don't have this because we already consider like 50 plus 50 plus 20 and 20. This is already we are having 140 GB memory is allocated, and we are remaining only 4 GB of memory in as per our diagram here. We had only 144 GB of memory. Out of that, we already allocated 140 GB, and next step we are having 20 GB of memory. So how this processing will get work? So this is where Spark's RDD management system come into the picture. So there will be memory abstraction. They will be located into the cluster memory. So content of the RDD, as I told you earlier, will not be edited. Like even though it is the memory, it cannot be edited. Why? There is a reason behind this. Especially like when you are having the larger data sets, some data is in the memory, some data is in the disk, and if you are allowing them to edit, suppose 100 partitions are edited, but the last one, like 101th partition is not edited, then management and tracking of the data will become very tough. The only way is transformation of the RDD and create a new RDD from this. So RDDs are the read only. So every time when you apply an operations like map, group by, you will end up having a new RDD from it, and the existing RDD cannot be edited, cannot be updated. So our question is like how we will get the memory for the last statement, that is T4. So when you execute this last statement, like val of T4 T3 dot map, which require 20 GB of memory, where we don't have this 20 GB of memory room available, system will do the make room available by removing the oldest RDD. In our case, which is TIMP. So now after this, suppose you have created few more RDDs, like suppose you are creating T5 and then T6, then T7. These RDDs also you created, and this T7 you want to join with the dataset 1. This dataset 1 you want to join T7 with TINP, which you created in the earlier, but there is, because there is no space available. So now to make room available, again the oldest RDD will be removed. In our example, which is the TIMPS. So Spark has a built-in mechanism to evict or remove unused RDDs to make room available, and this is done on the basis of criteria which is called as the LRU. LRU stands for least recently used. So your least recently used RDD will be wiped out from the memory to make the room available for the newly created RDDs. So now in this case, suppose our new requirement is like after getting the dataset S1, suppose we created one dataset S1 by using these two. I created dataset S1. S1 needs to join with again TINPS, this one, the second statement. But by that time I reach to the S1, there is a possibility that this already removed from the memory just to make room available for the next RDD. So it may evict, but the next statement, when it sees that you are trying to join with the S1, then it will go back to the memory. It will read that again data from the SDFS. It will process the original RDD, and it will prepare the next RDD, and then it will prepare the content, that is S1 joins TIMPS2, and it will create, suppose it is giving you new data set, that is J1. So this all is automatic. You don't need to have to do anything. This is comes under the memory management, which is making room available, is something that Sparks do automatic. One more point here I want to highlight, like suppose you are having data set S1 and you join it with TIMPS2 and you created, suppose, J1. This TIMPS2, if you really want to use it later, you know that as per the problem statement, you need to use this TIMPS2 data set to join with some other data set to arrive to a new data set. So Spark provide a way to deal with it, that is called as the caching. So once this statement is prepared, like suppose this statement, I can copy paste. Once this statement is done, the next statement you can write as TINPS2 dot CACHE. So now this will not become LRU collected, and it will not be evicted from the memory. So Spark will not remove that particular data set. Instead, it will remove the next data set, even though TIMPS2 is LRU. The concept is like it will not evicted from the memory because you already cached this particular data set, this particular RDD. So we are having one more way of doing this, that is persist. So when you are caching it, it will just maintain in the memory. Like suppose this is having some data size of 20 GB. So 20 GB space will be occupied in the memory, and memory is more important resource in whole Spark processing. And instead of allowing to consume 20 GB of memory, we can persist it. Like persistent provide different levels. Like I can persist memory at the memory serialization level. By using persist, this will be compressed and stored into the memory. So now suppose you are having previously 20 GB of memory, but after compression it can become 2 GB or 3 GB. So you can save enough a number of space, which is the most important thing while working with the Spark. So it is having the advantage, like you can save the memory by using the persist option, but there is one downside, like memory content is compressed and stored. So whenever we need it, it needs to be decompressed to use it. So saving memory by spending additional time on the compression and decompression, which is the downside of using the persist. So we can persist by using the memory only or disk only, anything. There are different persist options are available within this. Like for caching is going to store into the memory only. For cache, we are not having any options like uncache option, but for persist, we are having unpersist options available. So let I move you to next. So,
before you go to the next topic, there are 3 questions which has come in. I would like you to answer them as we go along.
Let me check the question first. Yeah, about the cost, someone is asking like about the cost. So if you are working on the TBs of the memory, and if you will go to the real scenarios, you will get easily like 120 GB of RAM is not a big deal. You get that. Generally, you are having the systems because data is more important than your cost. and it's not about the cost. Like you use commodial hardware which are not at all like very big costly things. Like only for the master node you are having high configuration and highly active uh, computer system, but commodial hardware are the ones which are very cheap available in the market, which used as the data node. Generally those hardwares are used in the hardware in the name node or data node. Next we are having some question. Until the program is complete, will the memory allocated node get free? Yeah, so that only I told you, like suppose there are, I have given the example, like I created 5 RDDs, and till the 4 RDDs I get completed. So in the fifth one I need 20 GB of memory, but I'm not having available 20 GB of RAM in my system. I'm right now talking about the RAM. The same goes with hard disk and other things as well. So I'm not having 20 GB of RAM available with me. So in that case, LRU concept will come into the picture. Means the first RDDs which I created, that will wiped out from the memory, which is of 50 GB in our example. So that 50 GB will available to us to use this. And in that case, if we don't want to remove that particular memory, remove that particular RDD from the memory, then we will use the caching option or persist option. Next, can you please explain why RDDs are required for Spark and why Spark can't work with actual raw data? I mean, why RDDs to be created? RDDs are in-memory processing. That is the thing I explained. Like with raw data directly, how you can process it. Like you need partitions. If you will do in the partitions in the next slide, in the maybe in the last slide, I will come up with the point. Even if you want, I can do explain you right now as well. So let me control that. So when you are writing a Spark program, there is something called driver, and your processing typically happens in the executor. So I'm sure you all are aware about the MapReduce. So what is the relation between the containers and executors? So in case of the yarn, there is a one-to-one mapping from executor to container. Whereas if you are, like we are having here 4 executors, I am considering here 1, 2, 3, and 4. Whereas if you are using Spark standalone mode or Mesos mode or some other execution mode, in those cases, we will not have this container concept. Only executor concept will be there. So which is conceptually both are the same. Executors are where your programs typically get executed, and executors are where your RDDs lies. Like executor is where actual processing will happen, and that all linked to something called driver. And what driver do? That driver also will be executed in one of the JVM that could be anywhere in the cluster. And driver is the one where your program execution will be started, just like your MapReduce driver. It will have the public static void main statement kind of thing, and driver will be initiated, and from the driver, whatever the statements you have written, those will be executed across the executors. So transformations and actions are executed in the executors, which will be distributed and parallelize the things. So if we do the parallelism and distribution, then the processing will be the faster. That's why we come up with the concept of the RDDs, not with the raw data, which was the question from one of the student. I can see the chat. Where is chat? I think I cleared with all the questions. If anyone is having, they can ask before I proceed further. Okay, I think so you all guys are clear with this. So let me move further here. So these are the concepts which we just right now talked about. Yeah, next we are having different kind of file formats, which kind of files we can have to deal with within the Spark. So we are having different file formats. One is the text file format, which is a simple file format, which is not the compressed one and very less used in the industry. Next, Parquet, ORC, Avro, and Sequence. So out of these, Parquet and ORC, these are the row columnar format. What is the meaning of row columnar is like all the rows will be stored as the columns and all columns will be stored as the row. So when to use Parquet and when to use the ORC, this is the one of the important questions which generally asked within the interview. So when you are having the row level delete and row level updates, then which are only supported by the ORC file format. So in that case, you need to go with the ORC file format. And certain columns which we generally retrieve together, then ORC is the used like better than the Parquet. Like we are having the age and date of birth, first name and the last name. These kind of togetherness is there in the data. Or you are having the address field, address having 10 fields. Those tend to be retrieved together. So in that scenario, this will be used. And where you don't have such kind of togetherness and each and every column is separated, then the Parquet is better rather than going with the ORC. But there are some disadvantages as well, like Parquet and ORC takes lots of time to load the data. Like initial data load time is like the hell. It's not even more, it's like hell. So you have to deal with that. But also it depends upon the scenario, like what kind of project you are working on and what is your client requirement and what operations you want to perform. It all depends upon that. Next, we are having Avro file format. So Avro is a file format which is recommended when your underlying schema of the table keep continuously changing. In that case, we will consider the Avro file format. Sequence file format, this is used quite in good amount in the industry. Like it is the compressed one. It is not a row columnar. It also not supports row level delete and updates, but it is compressed, efficient, it is faster, it is splittable. These are the few areas where it works. So then in that case, we go with the sequence file format. Avro and ORC generally we use in the production environment as per my knowledge in the industry. Next, we are having type of operations. So Spark support two type of operations. One is transformation, next is actions. So we have seen our programs like we used map and group by operations are there. So like transformations, it is an operation which work on a given RDD and generate another RDD. Like I have shown you in the example map I have used. I can show you other example as well. So other examples like filter, we are having join, union, intersect, group by key, reduce by key, aggregate by key. Those comes under the transformations. And actions, like it's an operations which may compute something and send output back to the driver or to a persistent storage. So like we are having collect, count, take, or save as the text file. Those will come under the actions part. Now, one more thing here I want to tell. So depending upon the file format, can you give example of file formats? So as Sandeep mentioned, like these all file formats will be covered in details later in the Hive module. So correct, like it will take a long time because I need to go to the Hive thing, not with the Spark thing. We have come across text processing in Spark, but would love to hear about the unconventional format like audio, video, sensor data. About the audio, video, and sensor data, most of those things will come under the Spark streaming concept. And before going to the Spark streaming, I will prefer you to first check what is Spark SQL, and if you will check how Spark SQL works, then top of that you should have the knowledge of the Kafka, how Kafka works. Then only you can get the things what is how Spark streaming get works. Spark streaming is like basically if you see the IPL matches, there is something called online at the time of voting option is there for the 20 seconds. They will record the data and display the data at the same time. So that is one example of that, of audio and video processing and sensor related data, like live kind of streaming is there. So then only you will get the understand. So right now let's focus on the Spark, then I will cover the Spark SQL. If I will get the time, I will explain that as well. That is not a problem for me. And so I was explaining like transformations are lazy. Someone was asking here like about the memory allocated it will not get free. So transformations are lazy, like they will be evaluated only when, like there are two scenarios, like when an action is invoked, action means you are having collect, count, take, save as the text file, then only they will perform. Or else there are certain transformations which will also force the evaluation, like we are having all the by keys operation as per the understanding point of view, like group by key, reduce by key, aggregate by key, or sort by key. In those scenarios only your transformations will be evaluated. Before that it won't get read itself. Like if I will write down the first statement as well, I have shown you this example. So until these three lines, if I will write, then also it won't get even read itself. I have provided some path here, but it won't get read from the file. Once it will show like there is something group by operation is there, then only that transformation will get evaluated. The first statement, then only it will run. Or any action is triggered. Action means like we are having t4 dot I can count or collect or take, t4 dot take, anything I write like this, or t4 dot save as text file kind of thing, and I will provide the path, then only it will get evaluated. Next, we are having a few stages. Stages are the sequence of the task that can be executed independently to other partitions. Like within the partitions, the number of sequence of the task, how they will execute, that consists of the stages. And there are two type of we are having aggregation. One is wide aggregation and one is narrow aggregation. So let me explain both of those two. So I first explain the narrow aggregation. So narrow aggregation is if each partition of the parent RDD is used at most one partition of the child RDD, that will come under the narrow aggregation. Like we are having map function is there, filter is there, flat map is there, join is there. Those are the narrow aggregation. And wide aggregations are the one which multiple child RDD partitions may dependent upon a single parent RDD. Like you are having group by key operation, reduce by key, sort by key, count by key. Those operations are comes under the wide aggregation. So these are the some of the important thing, wide and narrow aggregation. Next, we are having other features like we are having repartition, alias, and accumulator and broadcast variable. Okay, so about the repartitioning, suppose I am getting an output in my 10 files and I want to take that particular output in one single file. I want to combine them. In that case, I will go with the repartition concept. So like I will write down, like I created already one RDD here. I will write down, let me take you. I will write down like REP, and I will provide some path here where your RDD will get stored. So in this case, your output will get saved within the one partition itself. So if I will go and browse this file system, particular path, whatever I have provided, it would be like slash user slash cloudera slash live session slash spark slash telecom slash output one. So if I'll go to that particular location and check the files, then I will find all the details, all the data within the one partition itself. So in the background, what will happen when we do a repartition? So suppose you have 10 partitions and all the data will be sent to a single partition, and that's where it will merge them. So it is not at all recommended to use the repartition. Instead of that, there is something we called as the Coleas. We use that one. This is the one which we use. So I will write like this. So the reason is Coleus will avoid some kind of network traffic, like movement of data will be avoided. Whenever possible, it will apply local aggregation before actually sending the data to another partition. So that's why it is a more important point to be remember. So that is the only reason we are giving priority to the Coleus than the repartition. So repartition is not a recommended approach when you are decreasing the number of partition. Even though when you are increasing the number of partition, repartition is what we use. Next, we are having something called accumulator. So accumulators are global variables. They maintain the state across the executors and the partitions. So for that particular thing, we use accumulator concept. Next, other feature is broadcast variable. So broadcast variable is like if I have a requirement where I want to pass few certain data that needs to be considered or that needs to be excluded as a separate data set, and that data set is what we call as a broadcast variable. So in this scenario, what will happen is so as a first step, your name node, this is your first step, broadcast data is broadcasted to your executor, and in the second step, this would be your second step, local lookup while execution of that particular thing, like what is the broadcast variable, and considering that, then only it will start processing. So the data that you want to share, it will be broadcasted from your resource managed to all the executors. And so when this executor will be running, this broadcast variable data will also be available into the memory. It just take a local lookup, and based on that value of broadcast variable, you will decide whether it needs to be considered for that particular value or we should not. That decision will be taken at that point of time. So that is the benefit of broadcast variable. Let me check about the questions if anyone is having any. Yeah, the question is narrow and wide aggregation. So I already told you, like if you considering the parent as well as the child thing, it depends. So it will consider both. Like if each partition I'm having less amount of time, else I can draw and explain you one diagram as well. Let me show you if I can. So in the first scenario, let me consider the narrow aggregation. So each partition of the parent RDD, I'm considering this as the parent RDD. And this is your child RDD. So in the first case, like you are having a few operations, if you perform map operation, what will happen from the one, it will be one-to-one relationship between these two. I need to color in different shape. It will be one-to-one relationship. The same if you will go for any flat map or join operation, then also you are into one relationship only. And if you apply any other operation, filter operation, then also you are having the same one-to-one relationship from the parent to child. So that will comes under the narrow aggregation. And in case of wide aggregation, suppose I am applying for group by operation. So in that case, one parent can have multiple childs. So you can have this kind of scenario would be there. The second one, which I am right now telling. This can be the possible in case of wide aggregation, like group by key, reduce by key, aggregate by key, or you can have from this parent to multiple childs. That is one thing. I hope you cleared in this. Departition and coalias is repartition you will use when you are increasing the number of partition. Coalias is recommended when you are decreasing the number of partition. Coalias will avoid some kind of network traffic because it uses the local aggregation. Local aggregation means within the same partition it will do some kind of, if you are performing join no operation or some operation, it will do that first, then only it will transfer the data. Yes, you can say like it is more kind of combiner in a MapReduce, more like a combiner. Can you show us an example of use case of accumulator? Join operations comes under the narrow aggregation, right? Someone is asking, can you show an example of accumulator? Sure, I will do that. Give me one moment. So accumulator, I told you like we are having accumulators are global variables. They maintain state across the executor and partition. So suppose you are having the log tables related data, one log file you got, you are getting some error in the real time project and you got some log files because you are facing some problem. So you need to check the log files. In that log files, you are having 4 or 5 fields. Suppose you are having date, you are having some time fields, you are having time in milliseconds. Or you are having some log, you are having some level, you are having some class. So likewise, you are having these are the column values and you are having some data here, some data here, some data here. This is the one file which you got as a, and you need to now problem statement is like you need to find out where is the error keyword appears in this particular data. Like it can be here or it can be here or it can be here. So it's a very large file. It's not a simple text file of 1 or 2 KB of size. So how you will do this? I think the person who asked, like if he is having some idea, if he can tell how we can solve this problem. Else I will tell, no problem. I'm just waiting your answer. John, if you are having any idea, I'm having a file in which I'm having lots of data. There is an error keyword in that file. and I want to know like where exactly though that error keyword is coming in that particular file. I want to search that error keyword. It's okay, I will explain. So we are having general approaches like we will create a variable and initialize it to 0, and wherever you will come across through that error keyword, you will increment it. But this is naive way of variable based increment might not work in this case in our Spark, because there is a possibility of lose the track. As we know, like in my example, which I have shown you here, we are having 4 partition. We are having partition 1 here. Suppose you started with initialization of 0 and you find one error keyword here, and then its value is 1. The next time you will find error keyword, its value is 2. Next time you are finding, its value is 3. At the same point of time in the partition 4, if you will find the error keyword, it's in the naive way of approach, it should be 1, but instead of 1 we already counted till 3, so it should be 4. Instead of 1 it should be 4, it should count as the 4. So in that case, like it maintain the state of global as a global variable across the partitions and executors. In that case we use these accumulators. So this is the example. I hope you are clear with this. If not, I can show you with the programming as well. Okay, thank you. So we can consider this. Next, we are doing some kind of Spark performance tuning. So Spark performance tuning is the process of adjusting settings of records for memory, code, and instance used by the system so that Spark has the optimal performance. So increasing the performance is the main thing which we focus nowadays for anything, for that a Spark tuning comes into the picture. And tuning can eliminates those jobs that run for a longer time. It improves the performance time of the system. It guarantees that job are on the correct execution mode, and it all resources are effective manner we are using. It ensures that tuning. So tuning we can utilize by using the data serialization. Data serialization. All of you are expert in the Java, so Java serialization method you can use. Other than we are having something called Cairo serialization that we are using. We use memory tuning as well, for which consider the 3 things mainly, like amount of memory which is used by the objects, and how we are going to access those objects, and what is the overall of garbage collection. Those things needs to be considered for the performance tuning. Next, we are having memory consumption in the Spark, that also we consider it. Spark garbage collection, we consider it. So these are the consideration which we do under the performance tuning concept. So probably for everything, like it's in the real-time projects, if you will work, there is not even the single team who is handling that particular project. There is a particular team, generally called as the ADL team, who used to supposed to take care of all the infrastructure and other things. One person just asked about like costing of the memory of 120 GB of computer. So that is the taken care by some other team that is called as the infrastructure team, ADL we used to call them. So they used to take care of all server related activities, like how many servers would be there, how many data nodes, name node, resource manager, everything will be handled by them. So being as a developer, that won't be your job, but still like knowing is best thing if you, so that you can make your career in the build as well as the infrastructure side, admin side, both. So as of now, any questions? Because I completed with the Spark, I'm moving to Spark SQL. No questions. So let me move to Spark SQL. One question is there. Yeah, name node, data node are SDFS terminology. You can see in my diagram. Spark, one second. Are there cases that Spark cannot handle and MapReduce needs to be used instead? I will come up to both the questions. So if you, the person who asked, if you go to my first slide, it is a fast general approach for processing of the data. SDFS is for storage of the data. Right now we are talking about the Spark. So Spark is for the processing, not for the storage. Storage you will consider as the SDFS for, SDFS is for landing zone. And generally where your data exactly stored. So your data will be stored either in Hive or Impala, which is in the cloud data, or what about the metadata? For metadata, you use any database like MySQL, or nowadays one new um, framework is coming. I know it's somewhat old, but industry is moving to that. That is PostgreSQL. If you guys are not aware about it, just Google it and you will get more information. But from MySQL and other Oracle, people are moving to PostgreSQL. So that is for storage. And second question was something. What are the scenarios that Spark cannot handle MapReduce needs to be used? So nowadays, frankly telling, MapReduce is going out of the industry because in MapReduce, you need to write 170 or 180 line of the code. The same I can write by using the Spark within the 6-7 lines of code. And that is quite easy. And it provides 100x faster speed. So there is no point of using the MapReduce. So for Swapnil, like he is telling, if we are using some ETL process using the pig, so for the pig also, pig is also moving out of the industry. The reason behind pig is, if you will go to the background of the pig itself, at the back end, it convert your scripts into the Java code. Again, the same thing, like it will be converted into 170 or 180 line of the code. The script which you have written in the 10 lines, that will be converted into the Java program, and then it will get executed. So again, it will take long time, and nowadays time is more important. So time and memory both are important. So that's why there is no point of using pig or MapReduce. Everything is moving on the Spark, and Spark, you are asking about the real-time processing. So real-time processing, if it is streaming data, and then it will go to Spark streaming concept, else you can do with the Spark or Spark SQL. I'm not telling you to move to Spark or Spark SQL or anything. Like, you are a developer, so you should know your strength. Like, there is nothing like a scenario pig is totally out of the market. Pig is still there. If you are good in pig, you can make your career in the pig as well. But yes, industry is moving to the Spark. That is real thing. So it's better if you will learn Spark and other things. So Naveen is asking, so it's an executor whose memory is used, not the data node as in your example. So I cleared on that. What is executor and driver's memory? I clearly told you, like, executor is the one where your program is actually executed, and driver is the one where where your program get started. Like, simply public static void main is there. So all RDDs lies within the executor only. Saurabh is asking, can you please quickly go over process flow of Spark, like driver, Spark context, scheduler? Okay, I will consider in my next slides or somewhere. Yeah, we are having sc dot something I have written, sc dot text file. So for your questions answer is, like, basically Spark context is the which reads your code and it parses it. It prepares the execution plan and it optimizes the code that you have got. It prepare a physical plan, and the plan will be handed over to your execution engine behind your screen. behind the screen. So execution engine depends upon the mode in which you are executing. It can be yarn, it can be local, or it can be standalone, mesos, or Kubernetes. So in cell-based development, Spark Context is already available. But if you are creating your own standalone project like in Maven or something, then you have to create your Spark Context. So hopefully that will answer to your question. Spark 1 and Spark 2, there is no as such like speed wise, there are more speed wise, they improved a lot. Background processing, they improved a lot. Some new features they have added. Resource manager, yarn concept came into the picture. So some bottleneck was there in the Spark 1, which they removed in the Spark 2. I quickly cover the remaining slides, then I will go to the questions. So next we are having Spark SQL. So Spark SQL is a Apache Spark module for working with the structured data. So if you are having the structured data, in that case, we generally process with the Spark SQL. So what I was telling you before is like you as a developer, you should prepare yourself with your like if someone is good in the pig, then he can make his career in the pig. So right now, I personally for myself, I can tell like the same program I can write in, I can do with Hive and I can do with Spark, I can do with Spark SQL. So it's my thing, technology, like my thing, like how I will approach to that particular problem. If you are not sure how Spark SQL work and how to write the code in Spark SQL, then obviously you will go with Spark or Hive only. So that's the thing. So you should be knowing like, first you should be knowing like how things are working and which would be the faster or which would be the efficient and optimized. Second, like in which technology you are good in. You can do with any of these three or any of the framework. I hope this will help you. So Spark SQL libraries, we are having few libraries out there like data source API. Data source API is which is the basic building block of Spark SQL. And as the name says, data source API allow you to read the data from the source. And we are having something called data frame API. Once you read the data from the data source API, that will return a data frame and use this data frame to process the data. Next, you are having some interpreter and optimizer to express the data transformation in the SQL. And you are having some SQL services to get it work through the Spark SQL. Next, we are having something called architecture of Spark SQL. So one can use data frame, DSL, or SQL or HQL based on their own choice to process the data which is read from the source using the data frame API. HQL stands for here Hive Query Language, and DSL, I know you all are genius or domain specific language. So this is the basic architecture of Spark SQL. So data frame is a container for logical plan. Logical plan is a tree which represents data and schema. Every transformation is represented by tree manipulation. These trees are manipulated and optimized by the catalyst rule, and logical plan will be converted to the physical plan for the execution. This is the steps how it works. About the advanced concepts, a driver executor memory, I already covered. Memory management. Before that, I give you one example of Spark SQL as well, so that you will get better picture what is Spark SQL is all about. No questions as of now. So I just create one RDD. Well, of suppose T2 is temporary to RDD, and we are having something called SQL context here. This is the standard way of writing, like SQL context.read.json. If you are having the JSON file, if it is XML or CSV, then SQL CSV, SQL context.xml or .jdbc, whatever the file you are having. Then here you will provide some path, like you are having user slash some data. Suppose I am having some baby related data. So babies. So in the next step, so here I can show you. I have just now talk about the data source API. So this is your data source API, and whatever you created here T2, this is your data frame. So in the next step, what I will do is I will register this data frame as my temporary table. So for that, I am having something called register temp table. And I have given some name here. My tab is, this is just a name I have given to that temporary table. And then I will create one more RDD, like val of my output. This is the name which I am giving. And I'm using SQL context. I'm available here, dot SQL. And here I will write down the query, like select year, comma, average of count as C from my tab. Or if I want to make somewhat complex query, I can group by G by year, or order by C. C is the count. So it will give you year-wise birth count from a data which you are having, babies related data, child data you are having. So you can year-wise find out like what is the birth count there in that particular year. So this is the one example, like you just created in the first step some data source API. In the second step, whatever the data frame you got, you register that as the temporary table. In the third step, on that temporary table, this my tab which you got, you are just applying the operations. So this is the some example of Spark SQL. As it is not the recommended approach, Akash, but as a developer you can do anything, but it is not the recommended one. Like the same thing, if I am doing this, what I did here is, if I will run this simple query, select year from directly to the my hive, it will get work. And there is no point of using the Spark SQL, but that will take a longer time. So I need to explicitly add these 3 lines of code, understand this, and then I need to write code like this so that it will work faster way, it will work optimized and efficient way. So that's why we are using the Spark SQL. So if you are not okay, then you can write the single line as well. In the other case, you are telling, can we use the Spark only? So for the Spark, you are having, you can perform transformations and actions, and from those point of view, you can do that. Like here, I have written group by year here, like this. In that case, you need to apply this group by operation on your RDD, like group by key, and the same way you need to, there you are having the operator like order by key. If you will go to the standard Spark website, you will figure it out easily, like what is the syntax and everything. Even group by key I already shown you. Even though that was the somewhat you need to provide inside details in my the first program which I have shown you. I not kept, this is not the standard syntax. Here you need to group by key is there, and then you need to provide the details here as well inside the bracket. Then only it will get work. Even this is not the map is not the syntax, and I just want to explain about the memory. That's why I use these transformations. Hope you are clear on this. So driver executor memory we already covered. Memory management we covered. Few programs on Spark SQL covered. Some real-time project high-level architecture I just want to show you because I think you are not having industry experience of for the Spark. If you, those who are having, it's well and good. Yeah, this is somewhat high level of architecture, like which is generally get followed in. I'm not telling in all the projects or all the things are getting followed, but yeah, few of them are getting we used to follow out of these. Like there will be something called I'm not having highlighter here. It's better to copy paste. Yeah, so in I'm not telling like in all the projects all of the things will be followed, but yeah, few of them will be there. First you will be having something different data source, like it is non-SAP data, it is SAP data, external data, or any structured data, what kind of data you are having. Second, you will have something called data ingestion, like you are having the file landing zone, batch oriented, like in particular batches you will get the file or continuous ingestion, which comes under the Spark streaming. And this is the main thing which most of the project follows. They are having something called file landing zone. Generally Linux is the one. Next you are having information reservoir. This is the main area where all the big data related activities are taking care. So here you will have something called discovery platform, which is used mainly for to do the experiments. Like they use this area for the exploration purpose. There is certified program is there, which is IT controlled, so that we can have the certified information get to be published on your particular application platform. Then we are having something called data lake, where your all data resides there and get it processed, which is the big data activity involves. Then you are having something called in-memory data grid, which is generally not taken in the for the memory purpose. They used to save the data in the extra memory, but most of the projects not follow this. It is not added in the most of the projects. We are having certain level of support for the data validation as well. Something called storage would be there, which is basically for the data, whatever the data in the queue, those data will get saved here. You are having some data access and extraction layer, which is the layer when your team that has the data or other platforms who want to access that particular thing. So you are having the web services, data services, and connectors. All of you who are having the Java background, they all know about the what is the web services and connectors and other things. You are having some streaming services as well for data who is generating as a streaming, like live streaming data, as I shown you some IPL example, or if you have seen Big Boss or any other anything, like who is generating the data as a stream. So those related data, or any you can see like DID or any show which you are watching on the live voting option in the TV, those uses this streaming data. Then you are having something called information consumption and analytical methods, where you are having the multiple ways you can do it. By the dashboards, you are having the reporting, enterprise reporting, or DOC, or forecasting, or optimization. All these are the features which they follows. And some other tools are also used, like Tableau Talent for the reporting and other purposes. And at the same point of time, you consider the metadata management, security, master data management. So as I told you, like all the metadata will be reside in your one of the database, which is not a part of Cloudera. Like it can be MySQL, it can be any other Oracle, or anything. So which is going to be taken care here. And then your actual data will be reside in your Hive and Impala things. Any questions so far? I think no questions. So this is very high level. I'm not sure like how many of you got this, but yeah, this is a general approach which industry is following. So if anyone is having any questions. Yeah, so data source, as the name clearly told you, it's a source of the data source API. We just now talk about what is the data source. This is your data source API. This is your data frame which you are getting. RDDs are the resilient distributed data sets, and there is a out of this, one common question which is generally asked in the interview is what is the difference between RDD and data frames. Not these four. So what is the difference is RDD is only the RDD, but data frame is RDD plus schema. So schema means you are having the column name and data type and other things is also there. So instead of that, we can call it as the schema RDD as well. You can call schema RDD or you can call data frame. So if you want to use transformations and actions only, use can still do that on the data frame also, or else if you can run SQL because it has the schema attached to it, so we can use the data frame. So once you register your data frame as the temp table, and then on that table you can run all your SQL queries. So that's the way you will approach. And if you are having a data frame, you can add .rdd to convert it to the RDD, means it will skip out the schema and will give you the actual content. Similarly, the reverse also, if you are having a RDD in a place, you want to create a data frame out of it, you just add a schema on it, you will get a data frame. You can use for that a DSL as well. DSL is domain specific language. Like there is some example is like df.show for showing the all the records, or df.print schema for printing the schema, df.select a name.show for showing the particular names. So those things you can use the domain specific language as well. Which is the best programming language for Spark, Java, Scala, or Python? So it depends. Like I think language is not at all a big challenge for you guys, or for anyone. If you Google it, or if you will really study in 15 20 days, or max to max 1 month, you can learn any language. The main thing is the concept. If you are clear about the concept, then it's good. If you know the logic, then you can implement anything in the Java, Scala, or Python. Like for the map function, we are using in Scala slash and greater than symbol, but in Java we are using, as I remember, equal or greater than, if I'm not wrong. And in Python there is somewhat syntax difference. That's it. Language, yeah. Industry is looking, if you will go for AI related thing, like artificial intelligence, machine learning things, so they are preferring the Python. Other than that case, Scala is preferred. Java is also there, but in case of Java, the only problem is you need to write long code. So if you are okay with that, we are having lots of projects on Java as well. But Python, there is no foundation in that. You can implement in any way, but Python is generally used in the machine learning and AI. So if you want to make your career in the machine learning field, I will suggest you to go with Python or Scala, and generally Python. But that is not like 100% true. Like all the AI related or machine level related projects are implemented on Python only. There are few which are on Scala and Java as well. But that is the thing industry is approaching. Even Scala also, they are moving so fast, because in Scala it is quite easy to understand. Even just now also I have given you the example, so I think you all are clear on that, because it is very simple. If within the one line, just simple thing you need to take care about it. Like within the one line, like this is just for creation of the RDCs, these are some standard syntax, so it won't take much time for even a beginner or a fresher to understand this. But if you will go for Java, you know like how lengthy it is and how it is difficult. No, I am not telling industry is moreover looking at Python. I am just telling if you really want to work for MI and AI, then Python is recommended approach. But yes, so many Python libs are available in the MI and AI. That's why, correct. So that is suggestible one, but it's not like all 100% projects are in the Python for machine learning and artificial intelligence. I can say like 60-70% are in Python, remaining are in Scala or Java. But only for I'm telling for ML and AI field. Remaining field, there are so many projects, because if you will go, there are so many fields. As I initially told you, like we are for everything. If you will see for any online portal, anything, you are generating so much of data, which is needs to be handled and get to be processed. So there is a big future for big data for you guys. So need not to worry about the language. First learn the concept, and rest what is yours. Any other questions? So I suppose there is no more questions. So thank you all. I will say like all the best for your future.
Thank you, Ashish, for taking the time out, and I'm very happy to see that it's really informative session for everyone. And not only did you, got through the PPT session, but you also tried to explain the code behind it.
Thank you, everyone. Have a great day. Bye.